So in the first video we looked at the ways of making alcohols and reactions then of alcohols. We had fermentation, hydration, we got combustion, dehydration and oxidation as the main different reactions. Now we're going to look at carboxylic acids as our focus. I'm going to look at the reactions of carboxylic acids. So first, most obvious thing to say is they act as acids. So reactions that acids do are reactions that carboxylic acids do. So in GCSE you will have looked at some different reactions. So acid plus metal would make, let's just do it here, salt and hydrogen. You'd have looked at acid plus alkali makes salt plus water as a general equation, and then two more, you'll have looked at acid plus metal carbonate would make a salt plus water plus carbon dioxide. And the final one, which is really similar to that one, acid plus metal hydrogen carbonate makes salt water and carbon dioxide. The reason that one I'm adding on to the end is because in terms of balancing a metal hydrogen carbonate equation compared to a metal carbonate equation is ever so slightly different. So if we pick a carboxylic acid, let's go for the basic one first. So let's do ethanoic acid. So like this, react it with any metal. So let's pick sodium as a metal. It's going to make a salt. So this acts as an acid. What acids do? They donate a proton. So actually it's this proton that gets donated. So you get that forming. So the proton gets donated and actually ends up, we have two of them, so we have two carboxylic acids, and that ends up going to make the hydrogen. The O minus is then stabilized by the Na plus. So this is the salt that we form, which is so you got the O minus Na plus, there's an ionic bond, and this is a salt. So this is called sodium, because it's got sodium in it, sodium ethanoate. So ethanoic acid makes ethanoate salts. So sodium ethanoate is the salt. If this was propanoic acid and we reacted it with sodium, it would be sodium propanoate. Or for 4 carbons long, sodium butanoate, and so on with the naming system. You then need to just balance it. So if we put 2's in front of each of these, is then balanced. We've got the 2 hydrogens, which are then over there. So that's the first type of reaction. It's important that you can name the salts. So this one would be sodium ethanoate. Important that you can write balanced equations for them, like I've done above there. Observations for this reaction would be, the main one would be that it would fizz. So if that reaction happened, if we added a metal to a carboxylic acid, it would fizz because it's making hydrogen gas. Let's do a slightly different carboxylic acid for this one. So let's do propanoic acid. If we add an alkali to it, so remember an alkali is a base, so something that accepts a proton, so it's going to accept that proton right there. It's a base that is soluble in water, so it would be a solid as a base, but then if I add it to water it will dissolve. So an example of a base, I'm just going to pick a simple one, sodium hydroxide, aqueous, which is showing that it's dissolved in water. All alkalis would have that symbol because they've all been dissolved in water. It's going to make a salt, so salt, same thing happens as before, O minus, like that, and then the Na plus goes and joins. So now hopefully you can guess the name of that thing. it is sodium propanoate. So sodium ethanoate from ethanoic acid, sodium propanoate from propanoic acid. The other product then, just based on the general equations, we make salt and we also make water. So side product is water. Observations for this reaction is that it's exothermic, so the container would get hot. You wouldn't be able to see that happening, but it would be something, if you were holding it, you'd be able to see, you'd be able to feel. In terms of balancing, it's actually already balanced, so we've got H and then another H there for the two H's, and the O, so H2O, and then the Na has gone onto the oxygen, so this is already balanced, we don't need to do anything with it. Acid and a metal carbonate, so if I go, let's do methanoic acid, so just one carbon long methanoic acid. Let's do something other than sodium this time, so let's do potassium carbonate. So acid, methanoic acid, plus potassium carbonate, which is a metal carbonate. Clue is the fact that it's got a carbonate in it, is going to make salt, water and carbon dioxide. So the salt, K plus this time, because we've got potassium as our metal, plus water, plus carbon dioxide. And then we need to make sure that it's balanced. So I've got two potassiums there. If I put a 2 there, and I've also got two potassiums on that side. I'm going to need, then if I've got 2 of this part, I'm going to need 2 over here. So I think that's now balanced. Got one carbon, CO2, CO2. Yeah, so that one is now all balanced. I think like that. Last type is acid with a metal hydrogen carbonate, so let's stick with the same thing. Let's do methanoic acid again. Oh, I forgot to name this salt. So this salt, one carbon in it, so from methanoic acid, so it's going to be methanoate. Because we got potassium in the salt now, it's now called potassium methanoate. So name of that salt, potassium methanoate. So this methanoic acid plus a metal hydrogen carbonate, so let's stick with potassium hydrogen carbonate. So in this formula, let's go back to this formula first. You'd have had K plus and CO3 2 minus as your two ions, but you've got 2 of the K pluses in the formula that's cancelling out the 2 minuses. In this one, you've got CO3 2 minus, you've got a K plus, and you've got a H plus. So it's these 2 different positive ions which cancel out that negative ion. That's more of an aside, but hopefully useful for you. So same sort of thing again. The acid donates a proton, so O minus, and then we have the K plus H2O plus CO2. This time I think these just balance themselves. So H2, yeah, so these ones just balance themselves. You can check it if you want to. Now, one way they can make these sorts of equations really awkward for you if they wanted to would be to use a metal that forms a 2 plus charge. So if you look at all the metals that I use as examples, they're all from group 1, so they all form a 1 plus charge. If we thought of one that formed a 2 plus charge, so let me try, if we do magnesium as an example, so ethanoic acid plus, let's do magnesium hydroxide, so magnesium hydroxide aqueous, so acid plus, hopefully you can decide what that is. That is an alkali, so acid plus alkali is going to make a salt and water. So the acid gave up a proton, there's the metal. Hopefully you can start to see the problem that we've got here, and we're also going to get water as a side product. So the problem, in case you didn't spot it, is that we've got an O minus, but we've got two pluses, so the charges don't cancel out at the moment. So actually what happens in this sort of situation, instead of having just one acid attached to the magnesium, you'd end up with two acids attached. So there it looks a little bit like that. So we need to balance it accordingly. But that would be what would happen in this case. I think we need a 2 there as well to get the equation balanced. We could do one more example if you would want to. So let's imagine, what should we do? Let's do a carbonate. So methanoic acid again. Oh, in terms of naming this sort of thing, it's the same sort of naming system. So magnesium, and then you just would name the carboxylic acid. So it was formed from ethanoic acid, so magnesium ethanoate. You don't need to say diethanoate or anything like that, just magnesium ethanoate, because they'll know that it's a 2+ charge, so you would need 2 ethanoates anyway. So methanoic acid, let's react it with a metal carbonate, so let's do MgCO3. It's going to make a salt. So similar problem there, plus water plus carbon dioxide. Similar problem, easy to solve it, just have 2 of the acids attached to the magnesium, so same balancing I believe, 2 there. I'll check that in a second. And then this would be called magnesium methanoate. So let's just check the balancing. I think we're all okay. Yeah, we're good. So that's all balanced there. So that's reactions of carboxylic acids to make salts out of them. So lots of different salts that you can make using those. Okay, so the topic finishes then with how you make, how you turn a carboxylic acid into an ester. So an ester is a new thing. It has its own naming system, and we'll look at how to name esters as well. So if we say, so general equation, carboxylic acid plus an alcohol would give you an ester plus water. So in terms of what's happening between the carboxylic acid and the alcohol, water is being removed from them and they're being put together to make the ester and water. And hopefully you'll know the reagent that you use to remove water from things is sulfuric acid. So you would use sulfuric acid, aqueous, and you would reflux with the aqueous sulfuric acid. So let's pick an example and hopefully you'll see it a bit more clearly. Here we've got ethanoic acid. Let's pick a slightly different length alcohol, so let's pick propanol as our alcohol. What's going to happen is we're going to lose H2O. So these two molecules are going to come together to make an ester. The H2O is going to be lost. So in my reaction I'm going to make an ester and I'm going to connect these two up to get them to lose. So we've got this bit being lost, is now lost, and it's connected, that carbon is now connected to that oxygen. So O, C, 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 like that, plus H2O. So there's the H2O that I circled over here. It's an example of a condensation reaction because it's producing water. Two things are coming together to produce water, and it's connecting together. So this is an ester. This is the sort of thing, there's some hydrogens. This is what an ester looks like. In terms of naming it, it's very similar to how you would name a salt. So if we were to get rid of this bit, and let's say it was O minus Na plus, hopefully you'd be able to tell me that that would be called, if it was Na plus, it would be sodium and then ethanoate. Because it's not got a metal attached to it, it's got three carbon chain attached to it, it would be called propyl for the 3 carbon chain, and then same as before, ethanoate. So we'll do another example in a minute and you'll see the naming system, but we practiced before how to name these sorts of, if there was a salt, so let's say potassium ethanoate, and now all we've done is swap out the metal for a carbon chain, so propyl ethanoate. Let's do another example. So let's do a butanoic acid. So I already know now the ester is going to be called something butanoate because I'm using butanoic acid. If I do it with methanol, so there's my alcohol, methanol is being used, same again, so water gets lost, there's the water being lost. So I'll have 1, 2, 3, 4, double bond O, O, and then a carbon attached to it. H2O is a side product, which again, that's where it's come from. So it's important you know where it's come from. And then this would be called, so we've got a single carbon instead of 3 carbons as we had before, a single carbon. So that would be methyl. And then the part that we've practiced before, methyl butanoate. And that is how you make esters. And actually, when you're making this in practice, what you'll be doing is you'll have your reaction container, you'll have your carboxylic acid and your alcohol, and it'll be making the ester inside there. And it's actually an example of a reversible reaction. So what can be done in order to get the ester to separate out is you separate it by distillation. So instead of having the ester mixed in with the carboxylic acid and the alcohol, you can separate it by distillation, so you just end up with the ester.